is section 12.5, graphing logs. Tonight's homework is page 730. No, isn't it 725? Yeah, 725. Michaela, change that for me, please. 725, 1 through 12. Not 730. Alright, just as a reminder for last night's homework, which you will be quizzed on. The point of an exponent, the point of the log is to solve it for the exponent. So why do we do logs? Why do we need logs? The point of the log is to solve for the exponent. That's why we need them. Reminder on last night's homework. Why do we need logs to solve for the exponent? For example, you guys know that if you have 3x equals 9, you divide both sides by 3 and you get x equals 3, because the opposite operation of multiplication is division. You also know that if you have 2x minus 5 equals 9, you add 5 to both sides, because the opposite operation of a minus 5 is to add 5. You also know, Cesar, don't let me lose you, that if I have x squared equals 81, that the opposite operation of a square is to take the square root. We know this. But how do you solve when you have 3 to the x equals 81? The purpose of a log is to solve for the exponent. So if you have an exponent in your, you have a variable in your exponent, that's why we need logs. Just like you need a square root to undo a square, just like you need the addition sign to undo the minus sign, just like you need the dividing to undo a multiply. We need a log to undo the exponent when the exponent is a fraction, is a variable. So, as a reminder, example 1. Let's say I have 1/2 equals log base n of 3. You guys remember with Mr. Fuji, this guy piggybacks off the exponent equaling that 3. So this is the same thing as n to the 1/2 equaling 3. The point of the log is to give me the exponent. Anytime you have a log, whatever's on the other side is the exponent. The point of the log is to solve for the exponent. So if I have a log, whatever it equals, that is the exponent. So the way I used to remember when I was in your age, I would piggyback off that 1/2 and it would equal whatever that big base is. Well, n to the 1/2 equaling 3 is the same thing as the square root of n equaling 3. Remember, this is like the 1 here and the 2 here. So n to the 1/2 is the same thing as the square root of n. Let's do a little side note in case you forgot. n to the 3/4 would be the same thing as n cubed 4th power. Just in case you forgot. So n to the 1/2 is the same thing as the square root of n. Well, the square root of n can be solved by taking the square of both sides. So my answer is xn equals 9. Now how do you check? You say, okay, 1/2 equals log base 9 of 3. Is it true that 9 to the 1/2 is equal to 3? Remember, piggyback this way, piggyback off this, equaling that. So 9 to the 1/2, does that equal 3? You'll take out your calculators and check, please. Put 9 to the 1/2 and see if that equals 3. Is the square root of 9 3? Let's try another one. Example 2. Thanks, babe. Negative 1.349 equals 1/2 log of g over 1,000. Well, we're not allowed to do it yet because we got to get this log by itself. So I'm going to go ahead and multiply both sides by 2 to get rid of this 1/2. Mina, what's 2 times negative 1.349?
Negative 2.6898.
Yep. Equaling the log of g over 1,000. There's a number here whenever you have a log. Who remembers what that number is? Yes, ma'am. Jenny? It is a 10. Very good. If there's no number there, you guys, it's not like, oh, I guess it doesn't exist. The point of the log is to solve for the, help me? The exponent. So this is the exponent. But what's pigging back the exponent? There's no number here, Miss Riad. Yes, there is. It's just like an invisible 10. It's there. It's kind of like when we first learned variables, remember? They would just put x. What number is in front of that x? 1. It's the same idea. It's understood that a log base 10 is the same thing as not putting anything there. So how would I rewrite this? 10 to the, who piggybacks who here? 10 to the negative 2.698 equals what? G over 1,000. Well, 10 to the negative 2.698, let me give you 5 seconds to put that in your calculator, please. Sign, do you have your calculator, babe? Daisy, do you have your calculator? What'd you get, babe? I'll take that. It's around 0.002. And that's equaling G over 1,000. I'm not done quite yet. What do I need to do now? Multiply by 2. So G is approximately, when you multiply by 1,000, you get approximately 2. Let's do do one more and then you guys can do it, Doyo. Negative 0.101 equals x times the log of 0.3. Everybody notice here that we're trying to solve for x here. X is not inside the argument. So I just need to solve for x. How would I solve if this said negative 1.01 equals x times 4? What would you do? Divide by size by 4, right? Log of 0.3 is also just a number. It's a nasty number, but it's the same thing. So all I had to do is figure out what is the log of 0.3. Well, nobody in this world knows what that is by heart, which is why you absolutely need a calculator. I don't know what that is. So you need to know what log of 0.3 is by putting it in your calculator. Samantha, what is log of 0.3? Zero 0.5 or 0.0? 0.5 or 0.05, sorry. I'm not saying you're wrong, I just don't hear you. 0.5. Is that what everybody got? The log of 0.3? So what do you do with this negative 0.5? Why are we confused, guys? What'd you do with this 4? Divide. What are you going to do with this negative 0.5? Divide. We're going to divide. So divide both sides by negative 0.5. And Heidi, what is that? What is negative 0.101 divided by negative 0.5? These are both negative, so you know your answer is going to be positive. 0.032? Yeah. That doesn't sound right. 0.202? Heidi, you're a senior in my class. You should have your calculator, especially if you're trying to pass. Any questions on the example? All right, here's your doya. All right, 4 should have piggybacked that negative 3, and it should equal that. So 4 to the negative 3 equals 1 over x. Negative exponent means that you put it downstairs, so that's 1 over 4 cubed equals 1 over x. A negative exponent means that you put it downstairs. Well, 1 and 1 are the same. That means x has to equal 4 cubed. All right, example 4, we're going to continue on with graphing. And I need everybody to graph log base x on their calculators, please. Put that in Y1 and graph it. That's fine. Yeah. Answer is 64. Yeah.
So 1 over 4 to the power 3 is 4.
Correct. And 4 to the negative 5 is the same thing as 1 over 4 to the 5th. And 2 to the negative 3 is the same thing as 1 over 2 cubed. So that's the whole point of a negative exponent, is it pushes it downstairs. So what do you think would happen if it's negative and it's downstairs? Like, what's 1 over 2 to the negative 3? it would just be moved upstairs. So it's just too cute. You see the difference? So if it's negative, you just have to switch its placement. ¿Estás enojado? Sí o no? Alright. Alright, graph this on your calculator. You should have this. If I change the window a little bit so we could zoom in, you could see it a little bit better, like that. So now I want you to tell me what the domain and range of these bad boys is. So every log is going to look something like this. It just got maybe switched over, up, down, shifted left and right. And just like we did our exponents, you know how to shift something left and right versus up and down. 10 seconds in your group, remind each other. When do you shift up and down, and when do you shift left and right? Group 8, you're not talking to each other. Ashley, talk to your group. Cyan, talk to your group, please. How do you make any graph move up and down? And how do you make any graph move left and right? The negative is a reflection. How do you make it move left and right, up and down? Be careful, don't use the word parentheses outside the what? Not parentheses, not, what's the word you should be using? Outside the, yes, let's be careful. All right, so if I asked you for the domain of this function, I'm asking you to walk along which axis? The x-axis, very good. So take a good look at this. Where do you see no action? The negative side, very good. Is there any action over here? Where does it start? On 0 and beyond. How do you tell people that it's 0 and beyond? 0 to infinity, very good. I think you guys finally are getting domain and range. Alhamdulillah, it's me. Alright. Good job. It's not your fault. I think that you guys were not exposed enough to this in Math 1. I think you guys got to me and it's like, and I was like, why are they freaking out on me? I think if you would have played around more with this in Math 1, you'd feel better about it. But hopefully you feel okay now. How about the range? What letter are you, come on Riad. What letter are you looking for in the range? Now let's go up and down. What would the range be? Okay, so there's arrows here and there's arrows here. Is there any breakage? No, right? So you tell people that the range is all numbers, which is negative infinity to infinity. So because the domain is broken, what's the asymptote? So the asymptote is going to depend on that domain. You just told me that the domain is not all real numbers. That means there's an asymptote. That means there's like a break in your domain. What is the break in the domain? 0. But what's the letter? X or Y? X. Very good. So the asymptote is X equals 0. All right, based on what you know from example 1, now we should be able to do example 2, 3, 4 with no problems. So if I give you example 2, let's say this time I give you the log base x now plus 2. Now I want to ask you, what's the domain? What is the range? And then name any asymptotes if there are any. Go ahead and graph it for me. Kyle, why are you just sitting chilling, babe? What's going on? Yeah, honey? No, if it was in parentheses, it would be part of the argument, but it is not part of the argument. Jessica, is this an argument change or no? So does your graph go up, down, or left, right? Up and down. If it's a +2, does it go up or down? Very good. So it's the same exact graph that you just graphed, except it should have went up to. So you should be able to still tell me the domain and range and the asymptote. When you graph this bad boy, what is the domain? Angel? Why is it still 0 to infinity? Did it move left and right? So the domain's not going to change, is it? When is the domain going to change? If there's a shift inside the argument. Very good. This time it moved up and down. How would the domain change if it moved up and down? How would the domain change if it moved up and down? It didn't move left and right. Everybody see it? It moved up and down. So this time, the range is going to be different. Is it? So what's the range? How would the range change? Yes, it moved up and down, but there's still arrows on both ends. So does the range change? No. What is the range? It's still negative infinity to infinity. What's the asymptote? It's still 0. How come that didn't change? Because your domain did not change. So why would it change? Yeah. No, I think I'm going to do this one on Friday. Yeah. Let's try another one and then you guys will have a doyo. Let m of x equal log of x. Let's say they want me to do m of x is equal to f of x. Sorry, change this to an f. So sorry. F of x minus 5. This time, what's changing? You guys are scaring me. What's changing now? Why is the domain changing? Because it's inside the argument. Did I go right or left? I went to the right 5 units, right? So help me out. What would the domain be? Daisy, can you tell me? If it starts at 5 this time, it doesn't start at 0. Where does it start at? 5 or negative 5? 5. Very good. 5. It starts at 5 this time. So what's your domain? Good. 5 to infinity. It's still the same graph, except it got moved over. Actually, you guys are this way. Moved over. 5 units. Did it move up and down? No. So if your domain is 5 to infinity, you should be able to automatically tell me what the asymptote is. What would it be, Heidi? X equals 0, but that it got moved over 5 units, girl. Yep, x equals 5. Aldo, what's the range? The easiest points right here is that range. If you don't get this, I feel sorry for you, son. There's an arrow this way and this way. It's gonna keep going up and down the y-axis. There's no change in that range. Here's your doyo. Find me the domain, the range, and any asymptotes. Check with your group when you're done. Good job, babe. But what's the asymptote? What letter? Y or X? Make sure you put that. Kanoa, what's your domain? Good job. Therefore, what's your asymptote? Good job. So here, what's your range? Very good.
So, I have a question.
Yep.
When does the range ever change?
When does the range ever change for a log? That's a really good question. Guys, look at me. Please don't be distracted. When does the range, Isaiah, the exact opposite of what I just said. When does the range change for a log? Think about a log. Doesn't it just have arrows everywhere? Is it ever going to stop in either direction? So the range won't change.
Oh, so always be negative infinity to infinity.
That's why if you, I don't know, I feel sad when people get that one wrong. I'm like, oh man, that was a free point, bro. Like, really? All right, as a reminder, on your calculators, I need you to remind me, when is it reflected across the x and when is it reflected across the y? So please graph log of negative x, and then please graph negative log x, and tell me which one's reflected across the y and which one's across the x. I like when you stand. You're way more active, bro. I like when you're active. Sophia, can you help me out, baby? When you graph log of negative x, did it go across this way or down this way? Okay, I'll wait for you, babe. You just do it on the calculator. Ugh, I hate this calculator, bro. Where's the graphing thingy at? Where did you get this? How does I get it? Sorry, babe, I actually- maybe the menu? Oh yeah, the menu, graph, number 3.
So number 3.
Sophia, did you figure it out? This one? Or this one? The first one? Kayla, what'd you get? When you make the argument negative, does it reflect across the y or x? The y? Daisy, what'd you get? Kyle, what'd you get? Mina, what'd you get?
Y.
Alright, if you make the argument negative, it's reflected across the y. Remember the trick I taught you for the exponents? Remember if the x, the negative is the first, if it's before, then it's x, if it's after, then it's y. W, x, y, and, get it? So if it's before the log, it's reflected across the x. If it's after the log, it's reflected across the y. Now, is this going to change your domain? Yeah. You just like flipped it over to the other side. Is it going to affect your range?
No. Yeah, no. It's locked.
I don't know, Miss Riad. I'm going to stare at you long enough till you give me the answer. You guys are like... Is the reflection across the x or the y going to change your domain?
The domain?
What am I asking you? I'm asking you, is the x value going to change? Yeah, you just freaking moved it to the other side. Right? How about the range? Is it going to affect the range?
Range always is the same. Range always is
I know, but I just want to make sure that you know that. Do you understand that? Does it change the domain? I mean, does it change for the range if you reflect it?
No.
All right, give me a summary, please. Today I learned. I like that. Teamwork.